Good evening and welcome back, everyone. Let's continue our knowledge journey with the session which focus on optical technologies for next generation communication. Now I invite Ms. IP Pavitra, Assistant Professor from EC Department, to give an introduction about our resource person.
Good evening, everyone. It is my distinct honor to introduce our esteemed resource person for today's Atal FTP program. Dr. M. Ganesh Madan received his Bachelor of Engineering degree in Electronics and Communication Engineering from Madurai Kamaraj University and Master of Engineering degree in Optical Communication from College of Engineering, Guindy, Anna University. He was awarded CSIR UGC Junior Research Fellowship in Engineering Science by Government of India for pursuing PhD and worked as a research fellow at CEG Anna University for a short period and subsequently joined as a lecturer in the same institute during 1995. He worked for his PhD in the area of optical bistability in semiconductor laser diode under the joint supervision of Professor P.R. Vaya, Head of Semiconductor Device Research Laboratory, IIT Madras, and Professor N. Gunasegaran, Anna University, and obtained his PhD in 2001. He is serving as a professor in the Electronic Engineering Department at MIT campus from 2009 onwards. He also served as professor in charge of MIT Library for 9 years. He has headed the Electronic Engineering Department from December 2018 to August 2022. He has around 27 years of academic and research experience. He has about 90 journal papers, 100 conference papers, and 15 book chapters to his credit. His current research interests include design, modeling of optoelectronic device, radio frequency, and optical communication system. 9 scholars have obtained their PhD degree under his guidance. Currently, he is guiding 7 candidates for doctoral research in the above areas. He has guided a number of ME and BE students in the area of optical and radio frequency communication. He has also successfully completed 25 consultancy projects in the area of radio frequency and optical communication. He has successfully completed a research project for CVRD and DRDO with a grant of 9.8 lakhs. He is serving as a reviewer for international journals and conferences in the areas of optical and RF communication system. He also organized a number of short-term continuing education programs at Anna University. He has established state-of-art research laboratories for RF and photonics area at MIT campus. He has also served as the technical committee member in the Tamil Nadu government initiative on solar energy based streets and home lighting project during 2012 to 2013. He was elected as a member in Sigma Psi Scientific Research Society, USA in the year 2002 with International Young Scientist Fund. He is currently a senior member of IEEE, Fellow of IETE and Optical Society of India, member of EMC Society of India, Indian Laser Association and Instrument Society of India. Now I hand over the session to the resource person. Sir, please.
So thank you, Professor Chinnaya and other coordinating members of this Atal workshop. So in fact, I'm happy to be associated with this workshop, right? So now I will share the screen. So is it visible?
Yes, sir. Yes, sir.
So the topic what I will be discussing is optical technologies for next generation communication.
Sir, please share your
Yes,
PPT in full screen mode, sir. Could you
I
please?
have, I have put it in full screen. Now is it clear?
No, sir.
For me, it has come in full screen. Has it come?
No, sir.
And now is it visible in full screen mode? Sir, entire screen கொடுங்க sir. Presentation view entire screen.
Sir, Professor, sir.
Yes, I am in full screen mode.
Sir, speaker, sir.
Yes. So I have put it in full screen now.
Sir, actually, you please ensure that whether it is in entire screen. Once you are sharing, we will fix the entire screen means it will reflect as a full screen, sir. We will put in window means it will not reflect to the participants. So it's better you stop the screen sharing and again you share the screen and choose the first option, that is entire screen.
One second.
During sharing, we have to click the entire screen.
Okay, now what I should do in the screen share?
Yes, sir.
I should choose this and then you can select.
Yes, the entire screen. Entire screen. Share entire screen.
Where is that option coming?
The very first option, left top.
Left top. Basic share sound is there. Option is there. Then this is layout.
Sir, in basic, you choose the first option.
Yes. Basic. Basic. Okay.
Yeah,
basic.
Okay.
Choose the first option. Right screen, right?
Yes.
Now.
You put in the PPT in the. Yes, sir. It's perfect. Thank you, sir. It's perfect.
Okay. Sorry for this small delay. Okay. So I will move to the next slide. Yes, is it visible? Next slide.
Yes, sir. It's moving.
Okay. Thank you, Professor Dinesh.
Thank you, sir.
Dear participants, right? You had a very good session on the VLSI FPGA design, right, by previous speaker, Mr. Sarana Subramanian. Right now, my session will be on the optical technologies for next generation communication. So this is slightly a different aspect of communication. So everybody will be knowing about this current wireless communication, right? And most of you will have this 4G. And now in some parts of the country, 5G has already been started deployment. And we have a lot of expectations in 5G, but whether are we able to get all those things? What are the issues we have, right? And what are the possible solutions to overcome these limitations, right? And we all know in spectrum, the bandwidth is a very important resource. So how we can utilize the available bandwidth? All these things we will see maybe in the coming 45 minutes, right? And how to minimize the complexity and a few case studies, right? And finally, a word of caution. So in 5G communications, right, we have a number of demands, right? As a user, we put forth all these demands to the service provider, right? Service provider means like BSNL, Airtel, Jio, right? These people, right, are called the service providers. And as a user, right, we want very high quality signals, for different applications. So we all know in 5G, not only the standard video calls, right? Other applications are also possible. So the quality of signals are very important. In 5G, the massive machine connectivity, which is required for IoT, that is also right being taken care, right? So I think the Atal FDP, right? The title itself has IoT, and I think some of the speakers might cover the topics on IoT also. So coming back, so the demands of the user will be taken care by the service provider, and they put forth these demands to the technology development agencies. That means those agencies which are developing the technology to satisfy the requirement of the service provider as well as the user. So these demands will be taken care by the R&D units, right? For example, in 5G, if you are going for 60 gigahertz band or 27 or 28 gigahertz band, so in these bands, the R&D units, right, they should provide the hardware and software capabilities for these frequencies so that the user is able to get all the features. And finally, once this technology is rolled out, the economy. So today, if you see, lot of people use mobile phones, right, or even laptop computers for their small business, right? What they call it as a micro business. So manpower development is involved, and finally it leads to industrial growth. So all these are happening one by one. So the demands of the user, right? We are all users. So we want to have a seamless connectivity, whether you are in a stationary mode or if you are in a train, right? A high-speed train. We want to have a high-speed connectivity. And another thing is we want to download data, right? We want to do some online processing. Today, it is a very common scene in trains. We can see people even participating in online meetings in their companies. So many of us are witnessing this. Whenever we are traveling by train, we see people, right, with their laptops, right, joining online meetings, right? So that is the trend now. So connectivity, any place, anytime, right? And another demand of the user is less system complexity. So we don't want a very complex system. And of late, the security issues have come in a very important way because we come across online transactions, right, hackers, and lot of other online frauds are witnessed in the recent days. So our connectivity should have security aspects, right? So in this slide, I have just shown two small examples how the users in a bus or in a high-speed train, they are always connected. Next, as a service provider like Airtel or Jio or BSNL, they want to provide the service at a less cost. Then only more and more users will join. At the same time, they want to maintain a less complex system in the base station, maintenance free, right? and they also should provide huge bandwidth and capacity for the user. So other points like minimal outage probability, less data loss, and of course, coverage is very important. Today, if you see, if the coverage is not there by one service provider, immediately the users, they go to the next service provider, whoever is giving you a good coverage. Today, work from home, right, and online transactions, all has become very important, and users are unable to live without internet connectivity, right, or at least cell phone connectivity. So payment of money, right, ordering of online shopping, movies on demand, right, all these have now come into our pocket thanks to the cell phone technology, right? And now, as we are all EC engineers, in the past few slides, I told how, as a user, we want more capacity, right? And how the service providers, what is their role? These things we have seen. Now, as a simple example, we should all understand what is data rate. Why we need high data rate. All these things, right, are required. All these details are required, as most of the participants are from ECE or electrical or circuit branch, right? So one example, what I will show is the capacity of a CD player or a DVD player. So we used to watch movies, right? We used to watch movies earlier days using a CD player. Then CD player was outdated, then came DVD. So we watched movies in DVD players. Then we were very happy that the quality of the sound, quality of the picture is better compared to CD. Then DVD also is become obsolete. Now the current trend is Blu-ray, right? So, but the Blu-ray itself is almost 10 years or even more old. So, in this slide, are you able to see the slide with the capacity of these individual storage devices? I need some feedback. Are you able to see the screen? Is my screen visible?
Yes, sir. Visible, sir.
Okay. So I think our participants should interact. Then only it will be live. Otherwise, I am not clear whether the participants are there or not. Okay. So if you see this particular slide, the CD capacity is 650 MB, DVD is 4.7 GB, and Blu-ray is 25 GB. So what is the impact of this? We will see. So now I am showing a picture, right, which tells about the capacity and the quality. So in a CD, it is 1.6 micrometers, right? Now we have the next technology, DVD, which is 1.1 micrometer pit size, the size of the pit, which is used to store the data. Next, we had HD DVD, where it is 0.62 micrometers. Then we have Blu-ray disc, which is 0.48 micrometer. But the size of or the area of these disks are almost same. Because of the reduction in the bit size, we are able to store more data. So you are able to see a picture, right? You are seeing a picture, right? Are you able to see the difference between the left-hand side and right-hand side? Yes, anybody who, right? Are you able to see the screen? Are you able to see the difference in the picture?
Yes, sir.
Or is a slide?
Yes, sir.
So what we see is one side it is high definition, another side it is low definition. So left hand side we have more features compared to the right hand side, right? So more information is available, more information we require high capacity. The same movie, 1 hour movie, if you want to have more information, we have to store the movie in a Blu-ray disc whose capacity is 25 GB. The same movie, if you store in 650 MB CD, the capacity will be less. So that is the demand. Now this slide, I am telling you the clarity between standard definition, full HD, 4K and 8K. So that today all the televisions are available in the market with the 8K resolution and 4K resolution. So why I am saying this is, we are no longer interested in watching movies in standard definition. We want to see the movies in 4K or 8K resolution. So we have more number of pixels. The same picture, the standard definition gives you 640 into 450 pixel, whereas a 8K requires 7680 cross 4320 pixels. So more number of pixels, we get more information, more clarity. So this demands more data space, then it requires more capacity as well as more transmission rate. So this one has to understand why we go for high capacity systems or high data rate communication system. So I have put a comparison, a digital television. So the last row, if you see, video signal bandwidth. So standard definition is only 0.25 gigabits per second, whereas 8K UHD TV requires 60 gigabits per second. So this is one application which I am telling you so that we can
देखो
understand
ढूंढूंगी ना जो मिल जाएगा पहले वो चला दूं
what is
मेरा वाला
the
मिलेगा तो वो चला दूंगी
data rate and why do we need this data rate? For 0.25 gigabits per second for a standard definition, you require a carrier signal which is capable of transporting 250 Mbps, that is 0.25 Gbps. But if you want to transmit and see 8K UHD, you require 60 gigabits per second. So how to transmit 60 gigabits per second? One should think of what is the current transmission capacity. That is why we need to go from 4G to 5G. Then even 5G is not sufficient. We have to go for 6G and the next generation. So 5G, how it is different from the previous generation? It is cost efficient, energy efficient, hyper fast, low latency, ultra dense, and more than that, reliability. So these features make 5G attractive compared to the existing 4G. Right. So in the conventional wireless mobile communication, right, we have a very large cell area. So those who have taught wireless communication or what you call it as cellular communication subject, you will be knowing the current cell is almost 5 kilometer or 4 kilometer radius, large cell. And this has to take care the huge propagation loss. And because of large area, multiple buildings and other obstructions, we have multipath effect. And the existing is having limited bandwidth. And the channel is also non-uniform. And there are some places where you don't get the signal strength, they are called dead zones. But if you are very close to the base station antenna, there is a harmful RF radiation. So these are some of the limitations the conventional wireless cell phone system. So what to do or what solution, right, to overcome this problem? So what we will think of is to reduce this wireless distance or to bring the wireless close to the user. So what we can do is, instead of having a large area with one cell tower, we will have more number of access points, right, and transmit less power. Today we are transmitting in each base station around 100 watts of power, right? I have some calculation at the end, I will show you. So we have to use the existing infrastructure and we can reduce the number of such base stations, right? And this is what I called as a small cell. Instead of having a big cell, we will reduce it into number of small cells of diameter 1 kilometer. That's called micro cell. And each micro cell can have around 33 picocells. One picocell will cover 200 meter service. So some of the advantages in 5G, like it provides enhanced mobile broadband, massive machine communication for IoT, then ultra reliable, very low latency. And here we are expecting around 20 Gbps, right? And massive machine connectivity of 1 million devices per kilometer square. So these are some of the targets which are currently addressed, or what we say challenges which are currently being addressed by 5G technology. And we have a lot of techniques to implement. As I told you earlier, we cannot have huge spectrum allocated. Already spectrum has been allocated to various services. So we need to very cleverly and efficiently use the available spectrum, use different techniques for modulation, right, compression, encryption, so on. So we need to provide techniques such as cloud network, right, network slicing. All these things are evolving, improving day by day to achieve the required or desirable features of 5G. Right? So how this can be implemented, right? Like network reshaping, right? Mobile edge computing, various technologies are being developed. And we have connectivity from automotive to the base station. like what I told you earlier, train connectivity, right? And then in cars, now we are able to travel at a high speed. At the same time, we are able to browse. But whether we are getting the required quality, sometimes what happens when you travel in train, suddenly the signal goes off. And once you come to the minimal power level, then the signal picks up. So there is network disruption. Next thing is medical care, right? Technologies like AR, VR. These applications require a very high data rate and quality of service, right? And technologies like optical fiber, right, is able to provide you very less latency, right, and it can provide large bandwidth. So that is the one solution we are trying to provide for these conditions. So in the case of network reshaping, what we can do is instead of connecting one base station to another base station, right, through a wireless link, we can use the fiber network where high capacity optical fibers are being used. We can go for technologies like WDM, that is wavelength division multiplexing, or passive optical network for improving the capacity of the existing wireless systems. So this is one technology which is planned for 5G, where you can provide an optical fiber network which is going to directly connect the antenna. So when we are discussing about these technologies, we should know what are the current frequency requirements. If you see our country, most of the service providers, they are only operating in the first band called the sub 6 gigahertz band, 3.4 gigahertz to 3.6 gigahertz. Whereas the higher band is operating 24.5 to 29.5 gigahertz. So as I told you, even though this high frequency band is loaded, the technology of transmitters, receivers, transceivers, all the RF components, availability at low cost is going to be an issue at these higher bands. That is why in India, they have first started with this sub 6 gigahertz band for 5G. In some places, they have started experimenting this 24 gigahertz band for 5G. So, as we know, as the frequency increases, the channel loss is going to be high. So, what to do to provide the high frequency signals to the local access point? How to reduce the interference? But whatever solution we give should be lightweight, small in size, and it should be flexible, right? So the solution, what people are working is optical fiber based techniques for 5G, or in a very generic sense for the next generation communication, optical fiber techniques. So that is otherwise called as radio over fiber. So we can transmit signals such as CDMA or Wi-Fi or our old GSM, right, from the central processing station to the base station and back very easily, because this fiber provides very large bandwidth and the loss is also very less. Those staff members who have taught the subject will know that optical fiber is very minimal loss channel, around 0.2 dB per kilometer. Whereas in wireless communication is almost 100 dB at 2.4 Hz for 100 meters. So you have experienced this when you have a Wi-Fi point connected to your laptop. If you go beyond 100 meters, your signal will be lost. So the maximum coverage area is restricted. So this slide, you can carefully see how the base station, right, BTS, is connected to what you call it as access points, right, what we call the remote access point, RAP. The central base station is connected to remote access point through optical fiber. So by this technique, you can provide wide coverage and you can even connect to places where direct wireless signals are not available, like tunnels, area behind big towers, or shadow regions, or regions like mountains. We can have this technology. So you can have a doubt, can we use coaxial cable or any other medium? You all know coaxial cable is used very commonly for cable televisions from antenna to base station, but it is restricted only to a very short distance because the attenuation of coaxial cable at higher frequencies are very high. So comparing to coaxial cable, optical fiber attenuation is very, very minimal. And at the same time, the microwave waveguide which we use in the microwave lab, they are metallic tubes and it is not flexible. Weight, dimension is large. So these are drawbacks. So advantage of optical fiber is it is modulation independent. You can have different services. Simultaneously, it can transfer. You can integrate optical fiber with semiconductor lasers or detectors. Very less size and weight. And most importantly, it is not affected by any electromagnetic interference. Security is also very high. So these are some of the advantages of optical fiber, which enables it to be a better candidate for 5G and 6G. So this is the architecture where you will have the base station or control central station, right? From where the remote access unit is connected through optical fiber. And from there, you get the wireless signal to the user. So from the user, it is wireless to a very short distance. From there to the next stations, it is through optical fiber, both uplink and downlink. So what are the applications of this technology for 5G or 6G? We can have cellular networks like what I explained. We can have satellite communications, video distribution, mobile broadband service, wireless LAN service, vehicle communication control. All these are possible with optical fiber. That is why it is more suited for 5G and beyond. So whatever I said, right, I have given it as a point in this slide. So you just compare the coaxial cable loss at this frequency, right, 1.8 Hz. So what you see is uh, the cable diameter and loss, right, for 100 meters, 10 dB for 100 meter, but optical fiber, if you see, only 0.2 dB for kilometer. So it is totally lossless. So we can also connect the optical fiber to the antenna itself, as optical fiber is lightweight. So these are some of the advantages of optical fiber. So this is another diagram, how you can connect a central base station and remote base stations through optical fiber. So by this, a conventional 2 kilometer radius cell can be subdivided into number of micro cells with radius 300 meters. Since the radius is less, the power requirement also is less. So these are the advantages of microcellular system with optical fiber network. Still, if you want to reduce the power, or if you want to have more connectivity, we can go for still reduced cell size called as picocells, right? It will be around 20 to 30 meters, right? Picocells. So in this, the power requirement will be very less, right? And the size of this remote access units will be very small, like our handset. So remote access unit, right, is equipped with optical to RF, RF to optical converters. It has a laser to convert electrical signal to optical, an optical receiver for vice versa. You can have different services like data, video, voice, or any multiplex service using subcarrier multiplexing system, which can be transmitted through the optical signal. So this is another configuration where you will have very small cells which are covered by what you call it as remote access points. But the distance of these cells may be even 20 kilometers. So such architecture is not possible in the conventional wireless system. So this is another architecture where you will have the base station controller and mobile switching center, where you can have an optical fiber network connecting the BTS, base transceiver station, right? And the cells may be 1 to 3 kilometers. This is another architecture. So this slide shows you the size of the remote access point or RBS. It is the size of the matchbox, right? You see, it is very small and it can be easily, you can keep it in the hand, right? So this is almost 10 years old. So now the technology is still mature. So in the block of this remote base station, you will have optical and electrical to optical converter, diplexer, and a fiber connectivity. So you can have a single fiber for both uplink and downlink, or you can have individual fibers connecting, right? So the remote base stations, number of such stations can be connected right, using subcarrier multiplexing technologies. But we all know how different users can be connected in a network. Like most of us will know, in computer networks, we have topologies like mesh topology, ring topology, so on. So here also we can have different topologies so that we can use different wavelengths for different users, and we can also have different architectures so that the network doesn't fail, like what we call it as fault tolerant system. Today, in our country, we have networks such as RailNet or rail network, right, where you have the optical fibers laid along the railway track, and all the base stations are connected. And this is a very strong network called as RailTel, a rail telecom network. So that optical fiber network can also be used to provide connectivity to all the central base stations using this technology. So those who have taught optical communications will know about these modulators, where we can have an architecture where this wireless signal is sent along with the fiber to the home baseband. Fiber to the home today, our BSNL has launched maybe around 2 years back or 1 year back, fiber to the home. So optical fiber comes to the user premises, and from there it is wireless. Today, the BSNL has provided that technology, and we can have both fiber to the home plus wireless. So in our country, different service providers are providing different applications. But majority countries, there is only a single service provider. He is providing all the services. Only one service provider is able to give you wireless. Then he is giving you the cable television. He is giving you the internet. Right? So for such service providers, optical fiber technology has become very successful. So here I'm showing you the architecture, right? How the optical signal from the fiber is getting converted into a wireless signal and vice versa. So in the central site also you have laser diodes, pin diodes, transmitter and receiver. At the same time, in the base station also you have those systems along with power amplifier and low noise amplifier. Next technology, till now, what we have seen, right, is optical fiber-based technology. So this one, right, is slightly different. This is free space technology, right? I hope you are able to see the slide.
Yes, sir. Yes, sir. Yes, sir. Slide is visible.
Okay. So this slide shows the free space optics technology. See, till now we were seeing the optical fiber based technologies for 5G and 6G are what you call it as next generation. So now what I am showing is free space optics technology, right, for 5G and 6G or any other generation, right? So the technology is slightly different. We have, instead of optical fiber, we have the free space. Since the signal is passing through free space, you require a high power laser transmitter, and you should have different optics for that. Right? A fiber is a guided medium, whereas free space optics is unguided. So if you see this architecture, since the optical signal has to propagate through a long distance in free space, the power of the laser should be higher to overcome the losses in the channel, right? And in the receiver side, right, we get the data, and this is a bidirectional link. This is a bidirectional link. Otherwise, it is same. Okay, previous technology, we have seen free space optics. Now, the slide what I am showing is hybrid fiber and FSO. So this architecture from the central station, right, or the processing station, the base station is connected through optical fiber as well as free space link. So you have both these technologies available. So whenever this optical fiber is not functioning, or if there is a issue, we can entirely rely upon the free space link. Or if the free space link is disturbed, we can completely use the fiber. So this is another technology which is being investigated. Right, so I am just showing one case study. Right, this is a fiber FSO link. So this is the application where you need to connect the central office to a building. But in between these two, you have a mountain, right, and a river. Natural obstacles are available. So I cannot have a fiber link directly up to the end user building. So what I do is I take the fiber link till a particular distance, and from there I use the free space link. So this is called hybrid fiber and a FSO. Previous case it was parallel. So I hope you find the difference between these two. Here it is parallel, here it is in series, right? So you can transport the millimeter waves through the hybrid link for last mile coverage. So as I told you, this 5G is even working at 24 gigahertz. Optical fiber can easily take the 24 gigahertz through light carrier, and we can distribute the signal. So here I have shown a simulation setup right? Where I have a single mode fiber and I am transmitting a data, right, through optical fiber for 20 kilometers. For 20 kilometers, then I am splitting the power and sending it through free space channel and I am receiving it. So these are the blocks available for this particular architecture. So these are some of the specifications of the parameters used, right? Single mode fiber, what are the value of dispersion, attenuation, right? And the free space loss, all those things I have taken. And the simulation data I am giving. So it is a RZ data. So light output pulse, what you are seeing on the right hand side. And this is the eye diagram for one particular polarization. Then I am able to receive the data, right, next polarization. And finally, we calculate the bit error rate and capacity. So the transmission distance up to 0.8 kilometers, right, under different conditions. Because we know free space light propagation is affected by what you call it as atmospheric disturbance like fog, rainfall, smog. So clear weather, we will have a better transmission distance for a given data rate. So when you incorporate the different losses, how this capacity will be. So this calculation also is shown. So transmission distance increases, right? Then the bit error rate will decrease. So this graph gives you the bit error rate, right, versus distance and capacity, right, where all the losses, attenuation, geometric losses added. Right. Here also you have the attenuation, coupling, and geometric loss, how it is going to affect the bit error rate. So another case study. So those who are interested, you can see this. This paper is available in IEEE Explore, right? OFDM, which is very popular today, right? We have made a study on this OFDM signal at a 2.4 gigahertz, right? The optical fiber, and we have seen the performance. So you can see this IEEE Explore. Those who are interested, we can download this and read. That will give a clear picture of how OFDM signals can be transmitted through optical fiber to 2.4 gigahertz. So this is the block diagram, OFDM transmitter, optical fiber. Then you have RF, then you have wireless. So you have two things. One is optical fiber, then next is wireless link. So both forward as well as reverse. So we all know, those who are working in the communication, you know what are the basic blocks in OFDM. You have the data, and then you have the mapping, IFFT, then you have the RF transmission, and then the reverse. So this is a 2.4 gigahertz, 16 palm, 24 Mbps data. So these are the waveforms, right? Digital data, right? In phase signal, out of phase signal, then the RF signal, then the optical power in milliwatts. So the constellation, how it changes after different fiber distance. This I have shown. And we have calculated the bit error rate for different distance, right? 10 kilometer, 20 kilometer, 50 kilometer, 100 kilometer. So this study very clearly shows that how optical fibers are very effective transmitting OFDM signals, right, or any other digital data or wireless signals, right, that we can show. So one more case study I'm showing you cascaded fiber FSO for 5G applications. So here we have OFDM and RF at 3.5 gigahertz. As I told you earlier, in India, 5G is now sub 6 gigahertz, 3.5 gigahertz band they are using. So we have simulated that particular band for OFDM and 20 kilometers single mode fiber. Then it is transmitted through free space from 10 to 300 meters. Then you get the received signal. So previously we have shown that the constellation is undergoing rotation. So what we can do is after this demodulation of OFDM, we can use an equalizer to equalize this constellation error and get back the data. That is the overall idea for this particular study. So this is the application targeted. So 20 kilometer SMF, and after that you have the tower. And you can see the 3.5 gigahertz band. So the optical signal carrying this OFDM, I am showing you in the red color. And you see the scatter plot, right? So the results of this particular link with different atmospheric condition, we have strong, right, effect due to rain, snow, and fog. So strong condition means more attenuation, right? So we have calculated what is the error vector magnitude for different length. So as expected, under strong conditions, the distance is very less. So the climatic conditions will affect the free space optics transmission. So we have calculated the bit error rate and the transmission distance under rainfall, snow, and light fog conditions. So this is a 5G ROF FSO system, and we have plotted the bit error rate for various atmospheric conditions. So rain, snow, and fog. So when there is higher value of attenuation, 70 dB per kilometer, the transmission distance is very less, right? For larger distance, if you go, the bit error rate will be very high. So to summarize what we have seen for the past 45 minutes or 1 hour. So the current wireless technology, what are the drawbacks? What is a possible solution? Right? We have shown for overcoming the limitations. 2 approaches we have seen, microcell and picocell, which are all connected by optical fibers. Then we have seen how different architectures in optical fiber is able to provide you better performance. Right? So these are some of the references. So those who are interested in these technologies, you can see these references. As I told the agenda itself, the last point is a word of caution. So what is the caution? So this slide, when I say caution, there is some factor which we have to consider in these wireless communications. So I have taken this slide from Professor Girish Kumar from IIT Bombay. Okay, what is the issue? As we have said in 5G, lot of massive machine connectivity is there. You have broadband, high speed, all these things. But how are we getting this performance? How do we get high power? How do we get higher data rate? How do we get massive machine connectivity? So we all know that there is a formula called the Shannon's theorem, which states that the capacity is proportional to bandwidth, right? And we have signal to noise ratio. So all these 5G or even 4G requires very high power. So this slide, we can see the different wireless applications right from FM tower, TV tower, AM tower, Wi-Fi, cell tower, mobile phones. The second column tells the power. Last column tells numbers. So the RF sources in India, we are having around 4.3 lakh towers. Right? 4.3 lakh towers. And each tower is radiating, or it is having number of antennas, and it may radiate more than 100 watts or even higher than that. Your Wi-Fi hotspot is 100 milliwatts. Your mobile phone is 1 watt. So why we are showing this slide? Now itself, the entire earth space or the area is completely full of electromagnetic radiation. Full of electromagnetic radiation. This data itself is more than 15 years old. So this microwave radiation is classified into thermal and non-thermal. So while we are using mobile phones, when we are close by these base station towers, we are exposed to the harmful effects of electromagnetic radiations. So an example, the 4.2 kilowatt or 4,200 watts of microwave power will raise the temperature of 1 liter of water by 1 degree in 1 second. So water will absorb microwave energy and increase the temperature by 1 degree C. So if you keep the microwave oven, 1 cup of water, right, from 30 degree to 100 degree C, in 70 seconds, a cup of water, the temperature is raised. So most of you will be knowing this microwave, right, oven, where we take these puffs and other bakery items. They keep it in microwave oven, heat it, and then they give it to us. So the same example with 1 watt of our mobile phone, in 500 seconds, 1 degree C will be increased. Right? If you speak by keeping your mobile phone in your ears for 500 seconds, the temperature rises by 1 degree C. So how much is 500 seconds? 60 seconds, right? 1 minute. So if you use for 20 minutes, the temperature rises by 1 degree C. Right? So cell phone statistics, this itself is almost 10 years old. So 2010, we had 65 crores mobile subscribers, 4.5 lakhs of mobile towers. In 15 years, I think it would have doubled or even tripled. So as per the mobile phone usage, that depends upon a parameter called specific absorption rate. That is the rate at which the radiation absorbed by human body. Right. So a cell phone will radiate 1 to 2 watts of power. Right. The cell phone is having SAR limit of 1.6 watts per kg. Right. So with a safety margin of 3 to 4, we have to use cell phone only to a maximum of 25 minutes per day. So you have to use cell phone only for 25 minutes per day. Right? So this information is not known to people in India. So many manufacturers provide the details like SAR. Right? Even in your phone, you can find out what is the SAR. Right? And by taking the volume of your human body and how much time you use the cell phone, you can find how much temperature rise. Right? So just go to your mobile phone, find out the model, find its SAR, and check how much radiation is converted into heat. So the towers, they not only use one frequency band, but it radiates in different bands. So I have given CDMA, GSM, 3G, 4G, all those things. So the radiation pattern of the antenna is like this. So the people who are living in the range of 50 to 300 meters within the cell phone tower are directly exposed. That is dark blue. They are more exposed to the ill effects of electromagnetic radiation. So Professor Girish Kumar, IIT Bombay, you can go to his website and you can see a lot of such details. So he has done experiment and he has shown one tower which is directly focused to the 7th, 6th and 8th floor of a building. There are 4 cancer cases which he has identified. Right? So we need to be careful in using these electromagnetic devices in very close proximity. So now with these points, I conclude my speech. It is 9 o'clock. Now if you have any queries, feel free to ask.
Participants, you can ask any query to the professor. You can discuss with the professor. All your mics were unmuted. Please, you can discuss with the professor. Otherwise, you can post your queries in the chat box. Professor, on behalf of everyone, we sincerely thank you for your insightful presentation on optical communication for next generation, optical technology for next generation communication. Your expertise in optical technologies was evident, and we truly appreciate the knowledge you shared with us. Thank you for breaking down such a complex topics in a way that was both engaging and easy to understand. Your passion for the optical communication was inspiring, and we are grateful for the opportunity to learn from you. We deeply appreciate the time and effort you put into preparing this presentation. It was truly enlightening. Thank you, Professor. On behalf of St. Joseph College of Engineering and ECE department, staff members, and all the participants, we thank you so much for this presentation. Thank you, Professor. Participants, you can unmute your mics
and you can
unmute
ask
your,
doubts.
your camera so that we can take photos.
So there is
All
one
the
question.
participants are requested to unmute the cameras before concluding the meeting.
So there is one question, right? Somebody has raised, right?
All the participants are kindly requested to unmute the camera before we conclude the meeting for the day.
Yes, you can ask Professor Sinaya, you can unmute one. Madam Kavita has raised some doubt.
Yes, sir. Participants, in meantime, please unmute your cameras. We can take photos before leaving.
So there is one question.
Please unmute your cameras for dear participants.
So there is a question. As we use optical fiber in 5G, what is the effect of using NOFDM than OFDM? Right? As I told you earlier, optical fibers are independent of this modulation format or whatever may be the type of signal you want to transmit. We can transmit through optical fiber, right? Whether it is OFDM or any signal, even satellite signals, we can transmit through optical fiber, right? So that should not be an issue. So there is one person asking about the massive connectivity. So what is expected in 5G, right? The massive connectivity is more than millions of devices to be connected in one area of 1 square meter or so, right? Not square meter, 1 square kilometer.
Thank you all. Please, all of you unmute your cameras.
One person, why now fiber optics not costly? Because fiber optics, right, technology has matured and a lot of manufacturing units have come up. So fiber optics is become very cheap, and that is why what we see is even these service providers, after they lay the fiber, right, overhead fibers, once it is getting damaged, they are not even bothered to remove it. So they just like that leave it as such. Like any other queries? Some people are saying, right, the camera.
Yes,
Right,
now
any other
unmuted,
queries?
sir. Camera is now unmuted.
So I should thank all the participants for patiently listening and the organizers for making this event, right, a very successful one. We have more than 400 participants, right, that too in the late evening, right. Still people are, it's around 9 o'clock, right. They are connected and eagerly participating in the event and asking questions also. So I am very happy that you have all come up and joined in this course. So if there are no other queries, I should thank Professor Chinna and his team for organizing this session in a very excellent way and coordinating this FDP. Thank you.
Okay, that's insane.
Thank you, sir. Shall we wind up, sir?
Yes, sir.
Yes, sir. Thank you so much, sir. Thank you, all the participants. We thank you all. Please let us join tomorrow by 6 o'clock evening. Thank you all. Thank you for the participation. Thank you all.
Thank you all. Thank you. Thank you.
Dear participants, kindly fill the feedback for this session. The feedback link was posted in the chat box. So we request all the participants to kindly fill the feedback form. Thank you all. Thank you all. We request all the participants to fill the feedback form for this session. So the feedback link was posted in the chat box. We request all the participants to fill the feedback form for this session. Once again, on behalf of St. Joseph College of Engineering, we would like to thank all the participants for their continuous interest in the learning process. Thank you all. The feedback link was again posted in the chat box. We request all the participants to kindly submit your attendance through the feedback form. Thank you all.